Okay, so now we're going to expand what we learned about the angles in the first quadrants and their trig ratios to the other quadrants. So the first thing we're going to talk about is the signs, because basically what we're going to do is we're going to use reference angles and then what we know about the signs of each of the ratios in each quadrant to find the ratios for the angles in the other quadrant. So in the first quadrant, all 6 trig ratios are positive. Remember your trig ratios: sine is y, cosine is x, tangent is y over x, cosecant is 1 over y, secant is 1 over x, and cotangent is x over y. So because in the first quadrant the x and the y are both positive, all 6 ratios will be positive. Now in the second quadrant, the x's are negative, right? And when you're in the second quadrant, you have a negative x value. You still have a positive y though. So anything that has x in it will be negative. So that means cosine will be negative, secant will be negative, tangent will be negative, and cotangent will be negative. But sine and cosecant will be positive. In the third quadrant, x is negative and so is y. So any of them that have x or y will be negative. But if something has x and y in it, like tangent, you'll be dividing 2 negatives and that'll make a positive. So the sine will be negative, the cosecant will be negative, the cosine will be negative, the secant will be negative, but the tangent and the cotangent will be positive. And then the last quadrant, quadrant 4, you have a positive x but a negative y. So anything that has y in it will be negative. So that means sine, cosecant, tangent, cotangent will all be negative, but cosine and secant will be positive. So there's a little saying that we remember sometimes to remember this, and it's all students take calculus, ASTC, to remember what's positive in each quadrant. And then you just have to remember that cosecant is going to be the same sign as sine, and cotangent will have the same sign as tangent, and secant and cosine will have the same sign. So right down here it says determine if the value of each ratio is positive or negative. That's all we're telling on these. So sine of 240, since 240 is in the third quadrant and the only thing positive in the third quadrant is tangent and cotangent, this is going to be negative. 5 pi over 3. 5 pi over 3 is in the fourth quadrant, right? That's 300 degrees. So, excuse me, in the fourth quadrant, cosine is positive. And then tangent of 150, 150 is in the second quadrant. In the second quadrant, only sine and cosecant are positive, so this is going to be negative. Okay, so this is going to be one part of what we have to do to find trig ratios for angles in the other quadrants. Being able to tell what quadrant it's in and what sign it's going to have. Okay, so now it says sketch each of the following angles, find the reference angle, and then determine the value of the trig ratio for theta. You don't actually have to sketch. What you really need to know is the reference angle and then determine the value, right? So 330 is in the fourth quadrant. This is in quadrant 4. In quadrant 4, only cosine and secant are positive, so this is going to be negative. And then it'll have the same value as the sine of its reference angle. The reference angle for 330 is a multiple of 30. So it's going to be negative because it's in quadrant 4, and it's going to have the same value as sine of 30 because 30 is the reference angle. The sine of 30, you can use your hand trick or you can look it up on your unit circle, is 1/2. All right, cosine of 5 pi over 4. 5 pi over 4 is in the third quadrant, right? The top number is 1 more than the bottom. That's what the radians in the third quadrant look like. In the third quadrant, tangent and cotangent are positive, so cosine is going to be negative. The reference angle for 5 pi over 4 is pi over 4. It's a multiple of pi over 4. It's 5 times pi over 4. The cosine of pi over 4 is square root of 2 over 2. So this is going to be negative square root of 2 over 2. All right. So let's kind of summarize this. The special angles can be grouped by their reference angles. So in the other three quadrants, these are our first quadrant angles, 30, 45, and 60. There's a multiple of 30 in each of the four quadrants and a multiple of 45 in each of the four quadrants. So we're going to list those. So in the second quadrant, the multiple of 30 is 150. In the third quadrant, it's 210. And in the fourth quadrant, it's 330. All right. 45. You have 135 in the second quadrant, 225 in the third, and 315 in the fourth. And then 60, we have 120, 240, and 300. All right, so those are the special angles in each of the other quadrants. So all of these angles have the same coordinates, it's just depending on the quadrant. In the second quadrant, the x is negative and the y is positive. In the third quadrant, the x and the y are both negative. And in the fourth quadrant, the x is positive and the y is negative. Right? But other than that, they have the same coordinates. Same thing for all the 45s, all the 60s. Right? We've talked about how you can tell the reference angle. All right. So we can work through these problems. I'm going to pause the video and work them out, and then I'll unpause the video so you kind of do the same thing. See if you can figure these out using quadrants and reference angles, and then I'll explain it. Okay, so let's go over these real quick. So 225 is in quadrant 3. So in quadrant 3, sine is negative. And 225, the reference angle would be 45. So it's going to be negative sine of 45, which is square root of 2 over 2. So negative square root of 2 over 2. 120 is in quadrant 2. In quadrant 2, sine's positive. And 120 is a multiple of 60. So its reference angle is 60. So it's going to be positive sine of 60. And the sine of 60 is square root of 3 over 2. 5 pi over 3 is in the fourth quadrant. In the fourth quadrant, cosine is positive. And 5 pi over 3, the reference angle is pi over 3. And the cosine of pi over 3 is a half. All right, negative 135. Now, this is a negative angle. There's a couple of ways you can figure it out. You could find a coterminal angle. You could add 360. So it would be the same as 225 as far as what quadrant it's in. Or you can just think about positive 135 is in quadrant 2. So negative 135 would be in quadrant 3, just across from it. So there's a couple ways you can think about it, but it's in quadrant 3. In quadrant 3, tangent's positive. 135 is a multiple of 45, so the reference angle is 45, and the tangent of 45 is 1. 3 pi over 2 is one of those quadrantal angles, so I don't even really use reference angles for those. I just think about where they are. 3 pi over 2 is down here at 270. And at 270, the coordinates are 0, negative 1, and the cosine's the x. So the cosine would be 0. And then the last one, 11 pi over 6 is in quadrant 4. If you need to, you can change it to degrees. It's 330. In quadrant 4, tangent's negative, and the reference angle is pi over 6. So it's going to be negative the tangent of pi over 6. And the tangent of pi over 6 is 1 over the square root of 3, or if you rationalize it, square root of 3 over 3. So negative square root of 3 over 3. All right, so this is what we'll be talking about for the rest of this week and probably into next week a little bit. Just getting to the point where you can find these ratios for any angle on the unit circle.